All right, welcome to this video where we're going to talk about the relationships between pressure, volume, and temperature. And so we're going to talk about what happens to pressure if you increase the temperature, what happens to the volume if you increase the temperature, and what happens to pressure if you increase or decrease the volume. So we're going to talk about the relationship between those three variables. So we're going to take a look at the simulator here. We're going to put some gas inside of the simulator. Here we go, we're pumping some gas in there. And if you take a look, we've got our pressure gauge right here. Okay, here's our pressure. It tells us the atmospheres of pressure. We've got our temperature here, and obviously we can see the volume. All right, and the volume you know can change and all that. So the volume can increase or decrease or whatever. So what we're going to do is when we're looking at these different relationships, we're always going to hold one thing constant. Because when we're talking about, for example, pressure and temperature, we're going to hold volume constant. Whatever variable we're not talking about, we're going to hold constant. So we're going to start off by holding volume constant. What that means is the volume, the amount of, or the size of the container is not going to change. And what we're going to do is look at the relationship between pressure and temperature. So what happens if we increase the pressure? So I want you to ask yourself this. I want you to answer this question. What is going to happen to this pressure gauge if we increase the temperature here? So I'm going to add some heat here. What will happen to the pressure? Will the pressure go up or down? So let's go and take a look. If we add some heat energy, the pressure goes up. If we cool it off, the pressure goes down. This is called a direct relationship. A direct relationship means as one goes up, the other one goes up as well. As one goes down, the other one goes down. So if you increase temperature, you're going to increase pressure as well. All right, let's go ahead and look at the relationship between temperature and volume. And so what we're going to do is hold pressure constant. So we're going to hold the pressure constant. And what's going to happen to the volume of the container if we increase the temperature? Is the volume of the container going to get larger, or is it going to get smaller? So we're going to increase this here. So ask yourself this: will it get larger or will it get smaller once I increase the temperature? And here we go. Look at that, it gets larger. If you increase the temperature, you will see that the volume gets bigger. If you decrease the temperature, the volume gets smaller. And so this also is a direct relationship. As one goes up, the other goes up. As you increase the temperature, you're increasing the volume. And hot air balloons come to mind. So the hot air balloon gets inflated because they put hot air inside of the balloon. Now the last relationship is volume and pressure. So we're going to hold temperature constant, and what we're going to do is we're going to change the volume. What I'm going to do is I'm going to make this container smaller, and what I want to ask you is what's going to happen to this pressure? Is this pressure going to go up or down if I make the container smaller? Well, we make it smaller. Look at the pressure. It goes up. If we make the container larger, so if we increase the size of the container, the pressure goes down. And so in this situation, as volume goes up, pressure goes down. This is an inverse relationship or an indirect relationship, which means as one goes up, the other one goes down. So pressure and volume have an indirect relationship where as one goes up, the other goes down. So let's go ahead and think of these things as we're going through the notes. All right, so let's go ahead and talk about these gas laws. And the gas laws are simple mathematical relationships between the pressure, volume, temperature, and amount of a gas. And so what we're going to do is we're going to go through and talk about the different gas laws here. Just real quick, a side note from the kinetic molecular theory. Look at the gas particles at the top there. Notice how the gray ones are moving the fastest. Notice how the orange one is moving the slowest. And so what I'm going to ask you is which one has the greatest temperature? Out of all three of those, between the gray, blue, and the orange, which one has the greatest temperature? And remember, temperature is the measurement of the movement of the particles, the average velocity of the particles. Well, the reality is that they could have the same temperature. So keep that in mind, just a little bit of review from before. All right, so anyways, let's go ahead and get started here. The combined gas law expresses the relationship between pressure, volume, temperature, and moles. And so the combined gas law is an equation we can use to calculate the change in pressure or temperature or volume if another variable changes. And so we'll talk about this later. We'll look at examples of this later. In other words, we can take a pressure and volume, we can change the volume and calculate the new pressure. Or we can take a certain pressure and temperature and change the temperature to calculate a new pressure, and so on. And so the combined gas law does deal with all four of those equations. However, we typically are dealing with one variable within or one or two variables within that equation. And so a lot of times we're keeping something constant. For example, we might hold temperature constant, volume constant, or pressure constant, as we did in the simulator before. And so the following simple gas laws can be, you can derive them from the combined gas law. So here's the first one. Boyle's law states that the volume of a fixed amount of gas is inversely related to the pressure. And so volume is inversely related or indirectly related to pressure. That means if you increase the volume, you decrease the pressure. And that's Boyle's law. This is the equation for Boyle's law. It's P1V1 equals P2V2. And so what that means is if we start off with an initial pressure and an initial volume, and let's say the pressure changes, we can calculate what that new volume is going to be. Notice how temperature's not here because we assume temperature is constant. Then we have Charles' law, which states that the volume is directly related to the temperature. And so the relationship between volume and temperature is a direct relationship. As you increase one, you're going to increase the other. This here represents Charles' law. Notice how it doesn't have pressure in there because we're assuming pressure is constant. Now, something to keep in mind is that the temperature must be in Kelvin. So if you are ever given Celsius, you have to convert it to Kelvin by adding 273 degrees. And so if you take a look here, all right, next one. Gay-Lussac's law states that the pressure of a fixed amount of gas is directly related to the temperature. So pressure and temperature are directly related as well. And so that means that if you increase the temperature, you're increasing the pressure. Again, here is the equation for it. And you can see that volume's not in there because we're assuming that volume is constant. Again, temperature must be in Kelvin. All right, then we have Avogadro's law that states that the volume of a gas is directly related to the amount of gas that's inside of that container. And this is assuming a constant pressure and temperature. And a great example of this is a balloon. The volume of a balloon is dependent on how much gas is in the balloon. If you add more gas to the balloon gets bigger. And so that's a direct relationship. As you increase the amount of gas, you're increasing the volume, and that's Avogadro's law. Now, in your booklet, you'll see that you have the combined gas law, which is P1V1 over N1T1 equals P2V2 over N2T2. You can get any of those laws from that combined gas law. In fact, when we're doing practice problems, we'll always start off with that, and we'll just cross out the variables that we don't need. The other thing too is don't focus on memorizing which one is Boyle's law, which one is Charles' law, and so on. Don't worry about memorizing that. You won't be asked on the exam, oh, which one of these is Charles' law. So just focus on the relationships between those variables. If you increase pressure, what happens to volume, and so on. And that's it. Go ahead and watch the guided practice problem videos, and we will do some practice problems. It's really straightforward.